Afternoon, everyone. My name is Greg Lindhorst, and I'll be talking about taking PowerApps to the next level, doing some advanced formula, flow, stored procedures, server-side logic, all kinds of other groovy, cool things. I only have 45 minutes. I'm going to fly through a lot of this. I will not talk to every point on every slide. The slides are there for you to look at later if you so choose. I will definitely hit, of course, the big stuff. I'm going to talk about declarative logic, how we're very much like Excel, how you wire together applications using small formulas as opposed to monolithic procedures. I'll talk about imperative logic and how that plays a role in PowerApps and how you wire up buttons to do things on your behalf. And I'll talk about advanced topics like connectors and stored procedures. And at the end of the slide deck, there's a bunch of other advanced topics I won't have time to get to, but they're in the appendix of this deck that you can take a look at. So first off, declarative logic. 2 words of wisdom when working with PowerApps. Wear sunscreen. Oh, you guys are dead. Think Excel. Think Excel. This product was built around the concepts of Excel. It was a hypothesis that you could build an app as easily as you build a spreadsheet, and that you could lower the bar, make it simpler for people, standard people, non-developers, to build their own applications and solve their own business problems. In the course of that, we also want to leverage as much as possible skills that people already had, like Excel skills, like their knowledge of how to wire up formulas between cells and their ability to use functions that they already know, like if or sum or these other functions from Excel. So there's 2 kinds of logic exposed in PowerApps. The first is declarative logic, and that's where we spend most of our emphasis. It's around defining dependencies between things, very much like you define dependencies between cells in a spreadsheet. Controls are the things that we bind together. They're our cells, if you will. They have a set of properties associated with them, and they're set based on the value of this formula. That logic is automatically set in place, and in a sense, the application is constantly recalculating and showing the new values based on all of those dependencies that are coming into the formula. There's a whole graph that's kept in the background that we run through and make sure that everything's up to date. There's lots of formulas. There's lots of little things as opposed to large monolithic procedures. On the other hand, there's more imperative logic, things like Visual Basic or JavaScript or C#, where you define procedures, step 1, step 2, step 3, do these things in this order. You have larger monolithic procedures that do a bunch of things in sequence, and they have to be done in that sequence for it to operate properly. That means that a control's property can be set from many different locations, and that can be hard to understand where the value of this property is coming from if multiple places can be setting it, having an impact on it. So for example, in a declarative world, if I want to set the color of a screen based on 2 control values, in a declarative model, you just write the formula that says, the color of the screen is dependent on these other 2 things in this manner. And you lay out how that works, much like you would in Excel. In imperative logic, you have to deal with on-change of these different things. If the name changes, the first name changes, okay, now I have to go recalculate, and I manually do that. I have to go think about what procedure I need to run, and yeah, you can coalesce this into a procedure and call it from multiple places, but what if you miss one, and what if some rogue piece of code gets written that sets it in a different way than you expected? That's the beauty of being declarative and funneling it in through one formula. If you want to know what's going on with the color of the screen, there's only one place to look. It's that one line. If it's not happening there, it's not going to have an impact on the screen. Formula references, as I said, are very much like Excel. You say, B1 cell depends on the value of A1 cell. In PowerApps, you say that the property of this control is bound to the property of a different control. You set up that dependency, and then automatically the value 12 will flow from the text input box into the label. You don't have to think about it anymore. You set up the dependency. It'll be taken care of for you. Much like Excel, we also do references across screens. There's no concept of loading and unloading forms in PowerApps. The entire app is live all the time. Much like an Excel spreadsheet, all the sheets are live all the time. I can reference things on other screens, and they're going to give me the value I want all the time. I don't have to think about it. A PowerApp, when you say you want to navigate from one screen to another, you're really saying, I want to see the other screen. It's already been calculated. It's already set up. And we optimize that so we're not doing unnecessary work, of course. But it gives you the illusion that you can go to a screen and it's already there. It's already set up for what you need. So let's start with a simple example. On this screen, I have a background color that's derived from these 3 sliders, red, green, and blue. As I change the slider value, as I move it, the color of the background changes. Now, the way that works is based on this fill formula up here at the top. The screen has a fill property, and the fill property is set to RGBA of slider 1's value, slider 2's value, slider's 3 value, and then 100% to say it's opaque. So as I move the sliders, they just automatically recalculates, and I see the background color change. There's no on-change event for each of the sliders. There's no procedure that calculates this and stuffs it into the fill. Instead, the fill kind of pulls the value based on the value of its dependencies, which makes it convenient if I want to change something like the color of this text. It's fixed right now, but if I were to pull those sliders down, it would get really dark. So I can say something like, if slider 1 value is less than 50, make it white, otherwise make it black. So it stays black, but when I pull this value down, it automatically switches to white. All I had to do was define that dependency, and now from forevermore, that label will automatically recalculate based on that slider. And I can make that formula as complex as I want to pull in other values as well. What this means is you end up with applications that are a load of very small, not very small, but smaller formulas that describe what to do as your app executes and what the dependencies are, and then the imperative parts, which I'll talk about in a minute. This is one of our templates that ships with the product. This is a listing of all the formulas in it. Lots of them are really small, like item equals distinct. The on selects, the ones that are imperative, get a little bigger. The text here is saying is if blank, do a certain thing. But this is what applications and PowerApps tend to look like. They're a set of a lot of formulas. And we're getting better and better at presenting this to people. We've got an error checker now that was introduced recently. We're going to introduce a view like this as well in the future that allows you to get in there and understand what's going on in finer great detail than we do today. I want to touch on input and output properties quickly, only because it confuses people. There are 3 kinds of properties on controls. Some of them are input only. You can't read them. They're meant as just an input to the control. Some are input and output, kind of passes through, and some are output only. And so what I hear people say is they'll come up to a control like this text input, and they'll go, well, it doesn't have a text property. It's not in this list. That's because this list is the input properties. These are the things you can actually set a formula on. As text is an output, you can't set a formula on it. So it's not going to show up in this list. If you look at where it's consumed, though, there it is. I can use it in IntelliSense. I can write a formula based on it because it's an output property. So the only reason I bring this up is this does tend to confuse people that these lists are different because there are different kinds of properties. We did try to mimic Excel as much as we could. These are all the formulas or the functions that are in PowerApps. All the green ones are, as literal as we could, copies of what you do in Excel. We are trying to mimic as much as we can so that somebody who knows Excel can come in and make good use of PowerApps quickly. To the point where you can go to Stack Overflow and you can ask it, how do I reverse a string in Excel or do a reverse string search? It turns out somebody's done that in Excel formulas. It's this gnarly thing here. That works just as well for PowerApps. And the formula looks almost identical. It has references for properties on the controls as opposed to cells, but otherwise the same functions, the same way it operates is there. I'll go quickly through this I just want to do some background. There's primitive data types, more than you have in Excel. We introduced just recently a GUID data type because the Common Data Service for apps uses that as primary keys, and we want to make sure we could represent that well. So those are the basics you would expect. They're all nullable. Null in PowerApps is considered blank, like it is in Excel. So there's an isBlank function. There's a blank function which returns a null. There's also compound data types, records and tables that can be arbitrarily nested in within each other. This is how we build up more complex data structures. There are no arrays. If you want an array, you can do a single column table. We have facilities for making that easy than just you would normally find. And then there's table functions. Tables are a value. They are something that pass around. It's something that you take as an argument and something you get as an output. And we use this particularly for filtering, sorting, and shaping a table before we take it from a data source and move it into a control like a data table or a gallery. Go back one. Relational data. This is something new that we've been working on. We're very excited about it. I'll show a demo in a second. It's imagining a world without any keys and trying to make it as simple as possible for people to walk from one entity to another across a lookup. So for many to one, you can say something like product.supplier. And then off the supplier, we're now on this table, we can get the name. And we do that just by not dot notation, just straight across, like it was part of the object model. And the full object model is available to us. Similarly, for one-to-many, you can say something like product.reviews, which will return a collection of reviews, a table of reviews. And you can do that just with simple dot notation. That's new and experimental. I'll talk about that in a minute. You only need to bring in that root entity. You can just bring in the product, and then we can derive and navigate across all the relationships just from it. Keys are still available. If you want to use them, by all means, you're welcome to do so. So the example I'm about to show has products as an entity in the Common Data Service. It has two entities that have one-to-many relationships off of it, reviews and reservations. And this is showing the key representations, the actual keys that are used to make that work. And then finally, there's a many-to-one at the bottom for supplier that talks to the suppliers table. Since we're moving away from keys, rather making keys optional, how do you change things? How do you say, I want this new value to come in for a lookup? The way you do it is you assign the entire record in place. And we have functions like choices, which provides a table of the available choices for a lookup field. Now you may say, wow, you guys are moving so much data around. Isn't that horribly inefficient? Keys are just a single number or good. That'd be so much easier. It would be so much easier. But this we think is easier for authors to get their head around. And we do all that work in the background. We control the projection. We're doing analysis across the entire app about what data is actually used all the time. We'll only pull in the data we actually need to pull in. So although we give the illusion that you can get to everything in this graph, which can be quite deep, in fact, you can't. You have to actually type that notation. And if you can't type that notation, you don't want to go typing that notation too deep, then we don't bring it in. We don't need to. Okay, with that, I'm going to switch over to a test build. This is really new stuff that should be coming out within the next month, if all goes well. I'm going to connect to the Common Data Service. I'm going to pull in that products table, or entity, excuse me. Now, these three tables I'm working with actually come with the sample data when you install a new CDS instance. If you hit the checkbox that says install sample data, these guys are there and already interrelated. So here I've got products, the base entity, and we can make this a little nicer. First thing I'm going to do is I'm going to go get the name of the supplier as opposed to the rating to show here. So I'm going to say this item.supplier. You notice that dots march across the top, and then it offers me IntelliSense for the fields of supplier. I just moved from the products table to the supplier table, and now it's offering me the fields off of supplier, the supplier table, for this supplier. So I can pull the name. And just like that, it's in place. A couple of other things we've been working on are option sets. Spell it right. So an option set, we had a basic representation for a little while ago, but now we have a much better one, which I'll talk about in a little bit. put a form in place to edit the values in that list. Let's look at the supplier. Model, price. And let's hook this form up to the gallery. So if you're not familiar with the set, the gallery gives a selected property out of one of its outputs that says this is the one that's listed, the one that's currently selected by the user. We'll use that to drive what's displayed in the form. And then finally, this dropdown is defaulting poorly. Switch that to the primary name. So now with those changes in place, if I click between different items, the form snaps to show the values for that item. I did know, thank you. If I insert a button, now we can go to that top one. I would say Microsoft's getting in that business, so we'll take that. It'll write it back, and now the top item's been changed to Microsoft. The way this works, the drop-down is populated from the choices for that products field, for the supplier field, which returns a full record. We funnel that full record back into the system and say, okay, we want Microsoft's full record instead of Northwind. We pluck the primary key from it and then send that to the system and do the right things on the back end for you automatically. Now, I didn't show anything really cool there, new. I believe I promised new things. Let's try that. So in this data table, I'm going to pull in a one-to-many relationship. Just like that, I moved from the products to the reviews table, pulled in those fields, can pull in move it so you can see it. And so it's filtering the reviews table to just the reviews that are appropriate for this product and displaying that in the data table for me. And just like the form, it's going to snap as I change values. So I switch to this one, the form changes, and the data table changes to reflect that. Just automatically reflects those values. I didn't write any logic to like go get it or filter or blah. It's all taken care of declaratively. I haven't written a stitch of imperative code yet except for that button. Little white lie. Now I can do reviews. I can do reservations, which was a different one-to-many off that same object. Now I see the people that has reservations for this product. It's part of the schema. All this can be reversed as well. So I'm using a relationship between products to suppliers. What if we want suppliers to products? Easy enough. Bring in the suppliers entity. insert a gallery. There's no pictures, but we'll go with that anyway. And then again, I can go to Gallery 2 now. Now, suppliers has a collection for products. And sure enough, I click on the items here. Oh, the date is not very interesting, is it? Let's go with the name. Now I'm doing the reverse lookup. It's just automatically filtering for me. So we're hoping this will work well for people to build relational apps, to be able to walk relationships very easily in CDS and be able to build very interesting business apps on top of it. Okay. Before I move off of that, I was using something called an experimental feature. We've gone a little crazy with experimental features in the product. There's advanced settings, there's preview features, and we have a reasonable set of those. And then we have a long list of experimental features. This is but one of those. What I was just showing you is use the Common Data Service experimental connector. There's functionality there that's a breaking change from the previous connector, so we're going to have to roll it out in a planned and carefully managed manner. Part of those breaking changes, so these are the feature release stages. There's experimental, which means it's off by default. An author has to opt into it. It is not something you should do lightly. It is not ready for prime time. It is something we are continuing to work on. And in many cases, they are on a progression, and we really won't change it very much. I'll give you an example in a second where we will. Then there's preview. That means we think we're pretty much done with it. It's turned on by default for new apps, but we don't touch existing apps. We don't want to break existing behavior. This gives people a chance to get experience by using it and giving us feedback on how it went, and for people that are aware of this happening to start moving their apps to the new feature, to validate that there aren't any problems, that we won't break their app when it finally does roll out fully. At the end of that, we may have a final validation phase where we will we'll toggle it on one time and make sure everybody's cool with it before we turn it on permanently for good. And then there's a finally shipped mode. That's where it's out there. There is no switch to turn it off anymore. We have the new behavior. We love the new behavior, hopefully. In the case of the CDS connector, the reason it's going to go through this progression is that we are changing option sets. We're changing polymorphic lookups. Both of those have pretty crude syntax today, where there are separate fields exposed, underscore field value, underscore field label. That really should be just one field. There should be functionality to use the important pieces of that. In the case of an option set, it's really painful to go look up the values and figure out what the label matches with the value to use the right value. That all goes away because we take the option set and we actually make it an enumeration. So it's something you can just programmatically use. You can say .red, and we'll go look up the value for you, so you don't have to think about that. In the case of polymorphic, something we don't have any support for at all yet, really, but they are exposed there so you can see the type and the class ID. We really want to get away from GUIDs. People should not have to see GUIDs. It should be taken care of for them. And so that's where we're headed with that as well. So these are part breaking changes. We're also doing some stuff with date time values to make that better. Whoops. Oh, that's right. So how many people have used our barcode scanner control? Wow, nobody. Because, you know, it's not so good. There's one, two, thank you, bless your heart. It's really, really kind of bad, okay? What we did was an experimental feature for that. So if we look at this app, it's going to collect into a collection the scan barcode function. That's one of these experimental features that's in the backstage. You look at the settings. Down here, enable scan barcode function. I tell you, the new one is pretty remarkable. Here's my trusty iPhone. I hope. There it goes. This is running that app. 1 second. Let me do it this way. So I'm going to press this button, which is going to call that function. It's going to fire up this new scanner, and I've got some barcode scans, some not so easy to read ones up here. I've got a chocolate bar UPC. No problem, and very fast. And we lost video again. There it goes. QR code. Got that. Here's a Coke can with some curvy stuff. You can do a QR code on the side. There's that barcode. It is way better because we switched it from a JavaScript implementation to something that's native to the iPhone player and to the Android player. So that's running in native code and just returning values back to the app. But this is a case where we did an experimental function. We looked at this and went, that's great, but we shouldn't package it that way. And so what you're going to see before we actually release it in a couple of months is this function will have transformed into a control. It'll be a barcode control, and the reason for that is one of the problems with a function is it can only return one thing. I was just scanning barcodes, UPC codes, and QR codes, and I had no knowledge of what kind I had. I couldn't read it because I can only get one thing out. We could package it into a record, but that becomes really gnarly to deal with. And remember, I had to collect the value into my app. That's kind of gnarly too. It'd be nice if the control just held on to the last scan it did, and I can use that value as state throughout my data flow. So this is an example where we had an experimental feature. It's a great feature, but before we decide to make it to preview, to make it really what we think people should use long term, we're going to do some work on it, get it ready, and then make it preview. And then that'll be the signal that you can come and use this functionality with confidence that we won't be breaking it further. Okay. Something's not right. One second, let me close this, start over. That's where I wanted to be. Another experimental feature I wanted to call people's attention to is error handling, only because it allows people to push null values to databases. I heard a lot about that on the floor. People were avoiding nulls because we do a poor job with nulls, which is absolutely correct. Previously to this work being done, we thought nulls meant error. The folks that built Sienna, the precursor to PowerApps, null and error, that seems like the same thing. It's not. And so we've been retrofitting it so it understands what a null is independent of an error. And if you turn on error handling, you get that capability to deal with that. Okay, imperative logic. Whoops. There are things that you need to be able to deal with, events and state changes that Excel couldn't deal with. Excel doesn't have buttons. Excel doesn't allow you to set a cell's value. The user needs to set the cell's value. Excel doesn't let you change sheets. The user has to change sheets. Those are all things that you need to be able to do in an app-like atmosphere. So we avoid this where possible, but we fully realize that it's not always avoidable, and there's a place for it. And so we do our best with it. Some control properties like onChange, onSelect, onVisible, they're there so you can write a formula that executes instead of on the fly when it happens, as opposed to all the time as part of a recalc. There are state variables, global variables, context variables, and collections, which collect up state, and these functions are involved with making that happen. You can put a value into a variable that you can use in data flow through the rest of your application. But to set its value, you have to use one of these functions. This brings me to app analysis. I talked about a little earlier that we're always looking across the entire app to understand what data is flowing around, what data we need to have in the app. That's true. It's a strongly typed system. We need to know the types of everything as it's going along. And a good example of that is variables. You don't declare the variables anywhere in your app. And I often get the question, how do I get rid of a collection? How do I get rid of a global variable? You don't. You just stop using it. If you stop using it, we'll realize it's gone away, and it just disappears. It's gone. Everything is derived from usage. If you set something to a number, well, that's a number now. If you change it in your mind to make it a string, it's a string now. And then we do coercion throughout to get you the right values that you need in the right place. So here's a really simple example. I'm going to type some value into this text box. I'm going to set its priority. I'm going to add it to this collection. This data table on the side here is monitoring that collection and showing me the values in the collection. But the button, that's changing state. It's changing the state of the collection. Now with that collection, I can do things like filtering and sorting. Right now it's filtering by priority, where it's sorting by priority, and also filtering by priorities that are greater than 10. So if I go back into the app and run it, and you'll notice that the app is running live all the time. I keep going into preview just to make it big. Everything else happens directly here. I can just hit Alt and do something. Now, I just added that to the collection, but it doesn't show up because it's filtered out. That's part of the shaping of data that comes into these controls and how you manipulate the data before you actually present it to the end user to show. Bringing this all together, screen navigation allows you to move from screen to screen. So you define multiple screens, and then use navigate to move from one to the other. And you can pass state into it through a context variable, so that it's kind of like passing a parameter to a procedure. A good example of this is AFD. So when you're in the backstage, and you say new, you say start with mirror data, we call that AFD, or app from data. App from data creates a 3-screen app. And then it wires up the different pieces. It takes the data out of the entity, filters and sorts it, and moves it into the gallery. Then the gallery takes that data, whatever's currently selected, like we've been showing, and moves it into the detail screen and into the edit screen. Buttons like remove and submit work against what's coming out of the edit form or out of the data set to manipulate them. Screen transitions, there's navigate, there's back. These are all simple one-line formulas that move from one place to another. And then finally, there's a form mode. You can put the form into an edit mode or a new mode. A new mode, it's got blanks. An edit mode means I want to edit the current thing that's selected. So that's where it all comes together. If you want more details, go take AFD and decompose it, and you'll get an idea of how these things are structured and how they put together. Connectors. We have a slew of connectors, hundreds of connectors that are shared between us and Flow and Power BI, and a bunch of other properties on the Power Platform. You can also easily create your own custom connectors. It's very powerful. If you have a service that exposes a REST API, that's all you need to create a connector that can work with it. There are tabular connectors, like SQL, like CDS, like SharePoint, for which we can do CRUD operations. Most connectors are not that way. Most connectors, you pass some parameters, you call a method, and you get back a result. That result can be table-based, as I'll show you in a second, or it may not be. It may be returning a scalar. If a connector has tabular support, it kind of turns off the rest of the support for PowerApps. We can't call a stored procedure directly. We can look at tables and views from a SQL database, but we can't call a sproc. That's something we're going to get through. Delegation is a sore spot for lots of people. The PowerApp system, the filter and sorting I've been showing you, we can do a tremendous amount of work locally on the box, on the client, but that means we have to have all the data on the client, which especially on a phone, it could be really problematic to get all that data transferred over. Instead, what we should be doing is pushing those operations to the server, to the service, asking CDS, you sort it, you filter it before you give us the result, because you're in a better place to do it with more bandwidth to see all the data. We can't delegate everything. It results in these yellow bang warnings if we can't delegate it, and kind of a prompt that says, can you restructure this? Can you do something better? And you can't always, and we get that. We're working hard to make sure that there's less delegation problems in the future. We can push more and more to the server. But in the meantime, you're going to see that warning sometimes, and what it means is only 500 records are coming down to the client, and we're doing the local operation on just those 500 records. So be aware of that. You can crank the 500 up to 2,000, which will help, but it won't alleviate all the scalability problems you might have. There's lots of documentation, lots of stuff on the forums about delegation. We can easily start a flow and get a result from a flow. It's very powerful. Flow can work with non-tabular connector methods. It can get back tables. It can deal with, dynamic schema, something that PowerApps can't do. If you use the Visual Studio VSTS connector, Team Services connector, many of its methods return dynamic schema. The schema changes depending on the arguments you give to it. PowerApps, because we're a tightly closed system, strongly typed throughout, we just can't deal with that. Flow can, and it can wrap it, it can shape it in such a way that it becomes static, and then we can then consume it. And the same goes with stored procedures. So let me give you an example of that. Here I'm in SSMS. I've got the AdventureWorks database up on a SQL Server in Azure. I've got a stored procedure that I've written here that will do some group by summing and some analysis and shaping. It's doing SQL things, and that's going to return a result from the stored procedure. To make that work, to use it from PowerApps, what I'm going to do is use a flow, which is under the Actions menu. I'm going to create a new flow. Execute a stored procedure. Based on my connector that's already been established, it'll list me the sprocs that are available to me. It then knows about the arguments that I need. I'm going to give it a sample argument. Many things in Flow are about doing things by sample. Give me a run, and I'll take that result, and I can base things off of it. And that's exactly what we're going to do here. So I'm going to save that. I'm just going to call it. That's all I'm going to do. I'm going to save it, and I'm going to test it. It runs, and I get a result. And what I'm looking for is this gold down here. This is the result of the call for Utah. It has one item in this table. I'm going to capture the schema based on that result. And I'm going to say that is the schema I'm going to return to PowerApps. I'm going to fix it on that schema. So with that, I'm going to edit this, and instead of just ending, I'm going to have a response. The response action from Flow allows me to say, base the schema on some sample JSON. Paste it in here. And now it's derived that's an array of objects with these types automatically based on that run. Great. Now that I have this, I can take the actual result from the stored procedure and funnel it into that response action. And instead of just having this fixed to Utah, I can ask for the value I want from PowerApps. I'll save that. Back to PowerApps. Now I've got this PowerApps button. It's going to add that in an inconvenient place. Let's take it out of there. So I've got the run, and it's asking me for an argument. That's called customer state. So now it's going to run this stored procedure with that argument. The piece that's now missing is I just need to capture the output. And then I need to say this table, let's show the state results. Now, if all goes well, if I put Utah in here, I'll call and I'll get that one result. If I put California, I get a different set of results. If I put England, which really isn't a state, but it's in there anyway, I get results for that too. I don't know why. But I'm calling a stored procedure. Flow is doing the work of schematizing it for me into a way that PowerApps can figure out this is the company name, this is the state, this is the total sales, and then I can consume it directly within PowerApps. I am almost out of time. I'm going to couple items, and then we'll get to Q&A. I will stay as long as people want to ask me questions. I'm happy to hang out up here, and there's other PowerApps people in the room which can help as well. Business rules. If you're talking about CDS specifically, there's a bunch of stuff you can do on the server to enhance the logic that I've been describing. One of those is business rules. You can take actions on a record. So when you're saving a record, you can say that one field should influence another field. In this case, it's looking at a value and setting, I believe, the payment terms as appropriate based on the business rule. Now, there's only so many of these business rules that work in the Canvas apps. Most of them work in the model-driven apps. I've been talking primarily about Canvas apps. There's also another whole flavor of PowerApps, which is model-driven, which is based on more on the Dynamics UI that's been established for many years and is UCI and just being rolled out now. All the business rule stuff works in the Dynamics side of the house. Only some of it works in the Canvas side of the house. But we'll be enhancing that over time as well so that Canvas plays with all these rules eventually. Another important concept for server-side logic is CDS workflows. In particular, the synchronous ones. The asynchronous ones are interesting too, and the product recommends that you go asynchronous to reduce the load on the server and keep it under control. But if you need something to be transacted along with a change, you're going to change this table and you need some other change to happen in this other table. You need them to go together. If one happens, the other one has to happen. Then a synchronous workflow in CDS is the way to make that happen. It is server-side logic, much like a trigger would be in SQL Server. And it's very powerful. It has its own language for describing it. Take way too much time for me to go through that now. But if you dig into it, there's a UI in this builder for making that happen, and we'll be enhancing this over time as well. You notice that this UI is the older Dynamics UI that goes with the Solution Explorer. We'll be bringing this into the more modern portal experience that we have today. I'm almost done. Here's a set of resources. Many people ask me for this app that has been my deck for the presentation. It's posted at the very bottom there. So if you want to go download that app and play with it, you're more than welcome to do so. And of course, the slides will be available through the normal conference means for getting that, and I believe it's recorded as well. Please evaluate the session. I'd love to get your feedback on what I showed, what I covered. And with that, I'll open up to any questions. Thank you.